Hey everyone, welcome back. We're going to go over problem 62, right? So we have sine 2x. Let's just try to write it down. Sine 2x and cosine 2x, which is going to be 1/4. And I'm still having some kind of limitations on restrictions on the values of x, which is going to be for 0 and x and 2 pi. Right. So first off, if I were to find out solutions for sine 2x and cosine 2x, we've learned how to multiply two trigonometric functions, but again, this looks quite hard. So probably we need to change sine 2x and cosine 2x, the product of those two forms, into something that we know. And in order to do so, probably we got to remember fact 1, some kind of facts. And I would like to write it down as fact number 1, but since there's not going to be any fact number 2, I'm just going to write it as fact, right? So here we go. So I can write it down as fact, saying that sine 2x, or sine 2 alpha, is going to be 2 sine alpha and cosine alpha, okay? So you can actually write it down as sine 2 alpha equals 2 sine alpha and cosine alpha. Let's just try to switch that little 2x, this little 2x, into alpha. So in other words, we might have 2 times sine 2x and cosine 2x, which will turn into sine 4x, okay? Now, if I divide it out by half, you can check that 1/2 sine 4x is indeed sine 2x and cosine 2x. Does that make sense? So it's going to be something that we can now, this is something that we can use. Of course, I would just like you to remember this one. This is always true for any real alpha, okay? So we have 1/2 sine 4x, which is going to be sine 2x and cosine 2x. And imagine putting this back into the given form, right? So if I put it back into the given form, then I would say we end up getting 1/2 sine 4x, which is going to be 1/4. And of course, sine 4x will be 2 over 4, which is 1 over 2. And what are we looking for? We're looking for the number of solutions, the number of real solutions to this given equations. And we're going to use the same approach as the previous one, okay? So if I use the same approach, let me move this onto this part. And imagine we graph on x and the y graph. On xy plane, we can sketch sine 4x as 1 full rotations. And of course, there should be extra, cycles. And if I sketch the cycle like this, we get something about, the 4x actually tells us that we need to make sure that it's being shrunk by 4 sizes. So in other words, we have pi, we have 2 pi. It's really hard for you to see, but this is going to be pi over 2, and that shall be 3 pi over 2. In other words, in the original, in the original period, we need to make sure that there are 4 cycles getting stuck inside one, one full period, one full original period. Basically, we have shrunk, the original graph by 4 times, horizontally shrunk, right? So we have this given graph, and of course, it's not drawn to scale, but the maximum value is going to be 1, and minimum value is going to be -1. And all I need to do is just to draw y equals 1/2, which is going to be the horizontal line that is passing through this. So I can sketch the horizontal line just like this one, and it keeps going onward. And of course, my graph begins from, my x begins from 0 to pi. All I need to do is just to find out those intersection points. Now, how many intersection points do we have? Well, I would say we got, the 8 number of intersection points. So 8 intersection points means that we get 8 solutions to this equations. So that being said, the answer for this question must be 8.